Hey guys, I'll start this chapter Boolean Algebra, and this is a super simple, and you'll have a lot of fun in doing problems related to this chapter, and it's really simple. Okay, so let's start. Boolean algebra consists of two numbers only, which is it is a set of 0 and 1. Now, why it is called Boolean but not just algebra? Because since there are only two numbers involved, therefore it is called Boolean algebra. In the second point, 0 is often called false and 1 is called true. Or in some textbook they have written like 0 represent off and 1 represent on. But actually 0 and 1 are used to represent some voltages. 0 represent low voltage whereas 1 represent high voltage, because since computer is an electronic device, it does not even understand binary number as well. So but to represent, actually these are nothing but voltages. Some voltages are represented, so you learn about these in your like higher engineering. Okay, so operation on Boolean numbers. So in mathematics, we have operation like addition, subtraction, multiplication, division. So similarly, we perform some operation on these Boolean number as well. So there are mainly three operation, which is logical multiplication, logical addition, and negation. So we'll talk about uh, these operation like in the next slide. So truth table, you'll hear this word really often in this chapter. It is the combination of all possible input with their corresponding output. And I'll tell you what does this mean, and let's move on to the next slide. So I told you that we have some operation. So we'll learn about this operation, logical multiplication. So it is performed using AND gate. Okay. So now what is AND gate? Now since computer is an electronic device, and if you want to implement logical multiplication, you use one electronic circuit which is an AND, which is called AND gate. uh, so just forget about the electronic parts and all that stuff. You learn about these gates in logic design, but for now just remember that logical multiplication is performed using AND gate. Now the symbol of AND gate. So here I have the symbol. It looks like the letter D. Now these two lines are the input that you have given to this AND gate, and this is for the output. Okay. Now truth table for AND gate. So as I told you that truth table is nothing but combination of all possible input with the output. Okay. Suppose that we have this AND gate. So these are nothing but input, right? These two lines correspond to input, and this is the output which is given by this AND gate. Sorry about my handwriting. Suppose if we have given this AND gate x and y as our input, your output would be x dot y. So let us create the truth table. Truth table. Let me zoom in for you guys. Now we have two input, x, y, and the output would be x into y. So the possible combination of input are 0 0, which means both x and y are false. 0 1, which means x is false and y is true. 1 1 0, which means 1 is x is true and y is false, and 1 1, which means both x and y are true. So the output would be 0 0 0 1. let me open this slide for you guys. So in this, the fourth point, note output is true only when all input given to AND gate are true. So for this fourth combination C, both X and Y has the value as true or 1, you can say anything. So the output is also true. But for the rest of these three combination, since not all the input were true, the output given by the AND gate was false. Okay, if now the next question that might arise in your mind is, why do we have only four combination? Why not five or three, something like that? The reason why we have, there is one formula, number of combination is equal to 2 to the power input. Since we have just two input x and y, therefore 2 to the power 2 is 4. So we have these four combination 1, 2, 3, 4. If you have three input x, y and z, so the number of possible combination would be 2 to the power 3, which is 8. So I hope you're clear with this fourth point, why when will the AND gate give the output as true. So let's move on to our next operation, which is logical addition. It is performed using OR gate. So if you want to implement logical addition in the computer, so you use this OR gate. The second point, symbol of OR gate. Now here I have this symbol. So this is one curved line, and with this is how the OR gate looks like. Okay. The third point is regarding the truth table for OR gate. So let me just like open a new slide for you guys. So let's again talk about so this is how OR gate looks like. So this is the input x, y, and the output would be x plus y. So x and y are these are our input, and x plus y would be our output. Now how there will be four possible combinations, since we have two input. uh, they are 0 0, 0 1, 1 0, 1 1. Now the output for this possible for this OR gate would be 0 1 1 1. So let's look at our fourth point. Note output is true when at least one input. Look at this, at least one input is true. So from the truth table, you see, for the first combination, both the input x and y were false. So therefore, your output was false as well. But for the rest of these three combination, at least, which means one of them were true, or it can be all of them. Even if all of them are true, your outputs would be still true. Okay. So just remember that output is true, at least one input is true. So let's move on to our fourth operation, which is negation, also called prime or complement. So it is performed using NOT gate. Okay, so this is a symbol, like there is one triangle with a circle at the end. So the truth table for NOT gate. Okay, now so I have in the fourth point we have the symbol, so I have told you, and let's talk about the truth table. So before discussing the truth table for NOT gate, just remember that AND and OR gate can have as many input as they like. Okay, so in these two example, this AND gate is taking two input and this OR gate is taking two input, but the output produced is only one, and even for this one is one. But in case of NOT gate, it will only take one input and give you one output, not more than that. than that or less. Okay, so just remember, for NOT gate only one input and only one output. For OR and AND gate, as many input as you want, but only one output it will give you. So let's talk about the truth table for NOT gate. So here I have, so suppose this is our NOT gate. So you have given x as your input and your output would be x complement or x prime, whatever you want to call this, or it is also represented by x dash. Okay, so these both represent negation. So x and x complement. So since how many possible combination of input will you have? Since we have only one input, so 2 raised to the power 1 is 2. So x can take only 0 and 1. So x complement would be 1 and 0. So remember that NOT gate will always give you the complement of the input. If you have given NOT gate as 0, it will give you 1 as the output, and if you have given your input as 1, your output would be 0. That is the complement or prime of the input. So in the next video, we'll talk about some laws in Boolean algebra, and I'll see you guys in my next video.